Hello. Let's say we wanted to know, is the number 39,872 divisible by 7? Well, a really cool and slick way to check if a number is divisible by 7 is all we got to do is take the last digit and just erase it. So in this case, the last digit is 2. So we take the 2 and just erase it. We're left with 3987, but then we take 2 times the digit that we erased, and we subtract that from the remaining part. So take the 2 and just erase it, and we're left with 3, 9, 8, 7, and then just subtract 2 times 2, so subtract 4 from the remaining part. And what do we get? Well, we get 3, 9, 8, 7 minus 4 is 3, so we get 3,983. Now, does 7 go into 3,983? I have no idea. So just do it again. Take the last digit, erase it, so we're left with just 3, 9, 8, and then take 2 times that digit, so 2 times 3 would be 6. Subtract 6 from the remaining part, and we get 3, 9, and then 8 minus 6 is 2. So 392. Does 7 go into 392? I don't know. So take the last digit, just erase it, do it again. So we get 3, 9, and then take 2 times 2, which would be 4, and subtract 4 from 39, and we get 35. 35. So, does 7 go into 35? Well, yes, I happen to know that 7 times 5 is 35. So, yes, 7 goes into 35. That means that 7 also must go into 392. 7 must also go into 3,983. And 7, yes, the answer here is yes. 7 must also go in evenly to the number 39,872. What? Well, okay, I mean, that is true, but that just seems like a really weird and mysterious divisibility rule. Why does it work? Well, proving divisibility by 7 is actually not hard at all. Most people tend to know divisibility rules for 2, 5, 10. A lot of people know divisibility rules for 3, but 7, most people, I mean, they might know it, but if they do, they just think it's weird and mysterious. And they're right. It is weird. It is mysterious. But it is really also not at all hard to understand why does this work? Because what are we doing? We're just taking the last digit and erasing it. So let's assume that our last digit was 1. So if we're in a place value chart, I like to call a 10 to 1 machine. Now, in the language of exploding dots, well, the way we write numbers in base 10, we just use a 10 to 1 machine. So we have some number. If the last digit is 1, we just have a 1 or just 1 dot in the last box, in the ones space, in the ones box. And if we're erasing that digit, that basically means we're going to be adding a tod in the ones box. Because a dot and a tod, or an anti-dot, are going to annihilate. They go poof. A tod is like -1. 1 minus 1 goes to 0. So we just erase that last digit. But then we're adding 2 times that digit to the remaining part. So basically what we're doing is putting in 2 tods next to 1 tod. And what is 2 tods next to 1 tod? Well, in base 10, the rightmost box is worth 1. If we have 10 dots in a box, they explode. They go kapow and become 1 dot, 1 space to the left. So 10 ones would make 10, 10 tens would make 100, 10 hundreds make 1,000, and so on. So if we're putting in 2 tods, 2 anti-dots next to 1 anti-dot, so 2 tods next to 1 tod, well, that's like 2 anti-tens, 1 anti-1. That is just the anti-version. The anti-version of 21. And guess what? 21 is divisible by 7, right? 7 goes into 21. So all we're doing is just subtracting groups or lots of 21. And since 7 goes into 21, as many times as we subtract 21, that is not going to affect if the original number was divisible by 7. And there it is, a easy to understand proof that we can always check divisibility by 7 by just taking the last digit, erasing it, and then taking 2 times that digit and subtracting that from the remaining part. Calculator, take care.